I copy 2 lines where the applications can be found, and you can execute that in the place where you want this folder. So the first one is for copying the files, and then for decompressing them. So once you have the folder, you can go to the extracted file called for.application usage, and here you will find several folders for the different applications. So I will start with the R. So this is a very common application at HPC2N. And I will go to the folder R and see you. Here you can see the different examples that I collected for you. So there is a README file that you can follow, but I will explain the examples one by one. So the first exercise, the first example that I will show, it's called a serial. And if you go to the folder serial, you will see these two files. One is the batch file called job.sh, and the other one is serial.r. So in R, you can use R Studio as in your local machine. And the way to use that is to load first the modules for R. So if we take a look at the batch file job.sh, you will see that we can use this version of R, but first we need to load the toolchain as Birgitte mentioned. So I will do that. First loading the toolchain and then the version of R that we want to use. In this case, it's 3.6.0. And once you do that, you can load the R Studio. And it will get the R version that you loaded. So please notice that there are many different versions of R that are installed at HPC2N, and you should choose the one that fits your need. And here there is the standard R Studio graphical interface. We can open the file. And in this case, it's the serial job. And it just print out the hello world line. So we can here run the script. And this is something important because if you have a script which is heavy and it does many computations, especially if the job it's a parallel. So you will be occupying the resources on the login node, and there are many people that are connected to the login node, and they will see a delay, and they can interfere in the job of the others. So it's not recommended to run any heavy job on the login node. So for that reason, it's better to use the script file that I will mention in a moment. So, but this, as you can see, it's a simple serial job. Prints out just one line, and this you have. This is the standard RStudio. You can use that for very lightweight applications. Okay, I will show you again because this is also very important how to open R Studio. So first, we'll load the modules for R here. In this case, these are the only two modules that are needed. Then I load the R version that I need. And after that, I type R Studio on the command line. And then you should get the graphical interface like this. You can work and do your standard job here. So if we type on the command line ml spider and capital R, you will see all the versions that are available on Kebnekaise. So for this particular example, I use the 3.60, and if you do ml spider 3.60, you will see the dependencies, the tool chain that you need to load first. And this is what Birgitte mentioned previously. So, as I said, use R Studio just for doing some lightweight task. Don't submit a heavy job because then you will interfere with the others, and my colleagues will cancel your jobs if you are running on the login node. And how to deal with this situation? You cannot work on the login node. Well, you can submit the job to the batch queue. And for that, we need a batch job as it is here. So we need first a project name. In this case, is the one that you got for the present course, but this will expire. And you, if you are interested in working, keep working on our cluster, yeah, then you should apply for a new project. Here you request the time, and because this is a very simple example, just printing out a line, I am requesting for 2 minutes. And because this is a serial job, which means that the task will run on a single core, I am requesting just one core. And here is some output file for writing the output of the script. And also, if you get some errors, then they will be printed on a error file called error. And this percentage J refers to the job ID. So when you submit a file, you get a job ID, and this will be reflected here in this part. And I will show you that. So In order to use R, you need to do first this dependencies loading, as I did on the command line. But here you are now in a batch script. And after that, the R version that you need. And this is the way to run the R script. And notice that here I'm using some options for printing out the output of the serial job. And here is the way to run the R script. So in this case, you're telling R that you will use a R script. Okay, okay. Okay, so okay, thank you for telling me. I will speak slower. Yeah. So basically, you load here the modules, and here is the R version, and you saw that there are many versions of R, and this is just one 3.6.0, and this is the command line to execute the script in batch mode. So notice that you can use many uh, 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 options here for R, and I'm using here no save, no restore, but you can customize that depending on your needs. And this minus F, that tells R to use this source file called serial.r. So in R, there are many options. And if you type, for instance, R dash dash minus help, you will get all the options that you can use in your R script. Yeah. So in particular, in this case, I'm using no save and no restore. Yeah, and this will tells you a lot of output from R. Uh, some comment about this is that uh, not all packages work with the different versions, and it depends on the R version that you are using. You should check the package, and also if they run well with the version installed on Kebnekaise, you should check that always, especially for a parallel packages such as RMPI. Is you have some RMPI script, then not all the versions work well on Kebnekaise, unfortunately. And if you write a support ticket, we can take a look at it. So, but I found that this version 3.6.0 is very stable, because I haven't had any problem when installing some package. So once you have this script, you can submit it with the sbatch command and the name of the script. So this is the proper way to run it. So I will do it. So notice that I get this line, submit batch job, and this number. This is the so-called job ID. So now, because the job is really fast, it won't take a long time, longer than 1 minute or much more less than that. And I can check the status of the job. If I do, for instance, execute this command, sq minus a minus u, and my username. In this case, is p Ojeda-May, but Ojeda-Ma, but it depends on your 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 username. You should put your username here instead of mine. So you can check the queue, and it should be empty because it already finished. So, but if your job takes a long time and you want to monitor the resources that you are using, then you can use this tool called job usage, and this number here, which is the job ID. And if you do this, you will get a URL, right? Which you can then copy and paste in your local browser. I will copy, and in my local machine, preferable, I will paste that. And here you could monitor uh, how much you use from using from the CPU and the GPUs, and also the memory. So because this job was quite fast, I cannot see any statistics. In order to see the statistics, you need to wait a few minutes after the job started. But this was quite fast that I cannot see anything on that web browser. So this is a good way to monitor uh, the resources that the job is using, especially if you are using, for instance, many nodes, many cores, GPUs, because sometimes one can make a mistake and, for instance, request the 28 cores, but at the end of the day, one is using only one, right? So it could happen, and then you are wasting your resources, and then some cores are being idle. So this is a good way to monitor the resources, not only in R, but in general. Okay, so let's see the files that we got from R. We got the two files called error and output, and notice that the percentage J has been substituted by the job ID, which was a number obtained from batch. And we can take a look at the output file, and you will see plenty of information from R. And finally, we'll see the real output from the code, which is just a hello world. Quite simple. I prefer to write uh, all the output from R instead of just printing the real hello world line, because it is more instructive. And in the case of the error, so it only tells me about some modules that were loaded, and that's because for this case, I already loaded R, as you can see here. And in the present case, I didn't use the ML purge here, which is the line recommended. So, but this was just a type of warning message. It was not a real error, because as you see, the code was executed properly with R. This was just a warning, and this output is directed into the error message. Okay, now we can go to the next example. And if you go to the folder called job arrays, you will see again two scripts. And what are job arrays? Uh, so imagine that you have some script, and the difference between one run and the next one is just the value of the parameters that you want to change. For instance, if in one of the simulations the population is 1,000 individuals, and in the next simulation you want to do is 1,500, for instance. So just a difference in the parameters. So for that option, you can use a job array, and the script looks as follows. Again, is the project ID, the time, and here there is a difference in that we ask for an array, and this array will go from 1 to 28 tasks, right? And here I will write the output into one file called array test, and these two lines will be substituted by the array numbers and the array IDs. And also, as I did before, I will write an error message, and each independent simulation will write both an output and an error file. So here there is the tool chain that I need for R, and here the R version, and the way to run the script is very similar. So you may be asking, so what's the difference in the dependent runs? And for that, I can open the script, and you will see that here on this line, I'm using a environment variable from Slurm, which will allow me to change the parameters. So in this case, I'm using this variable to give a job ID to each independent task. And then this variable will be printed out as the job array ID. And after printing out, I will just wait for 30 minutes, and then I will print out the variable. So if you see, the only difference in this script, the script is the same, but what it is changing is the parameter. And I'm controlling that by using a batch environment variable. So what I will do now is that I will print, I will execute the command. So what I will copy the project name, and I will submit the job as before with sbatch job.sh, and just submit that. And if I check the queue with my username, you should change that. You will see that there are plenty of jobs, 28 actually. And the job ID is this one, but it has a underscore with the job ID. And now because I'm running independent instances of the serial code, I will get a series of outputs, right? So notice that these job arrays are useful not only for R, but for other software as well. But in R is convenient because some of the scripts are in serial mode. They don't require, for instance, 28 cores in parallel, but just one core. And sometimes people are interested in running many instances of the same job by changing just a few parameters. So let's check one output, for instance. I will check this one, 19. And you see at the end of the script that it prints out just the ID of the job. Okay, so you can also monitor the job by using the job usage and job ID as before. So the next script that I will mention is about RMPI. So RMPI, if you are familiar with the message passage interface, this is just a a simplified layer of MPI that runs together with R, and it allows you to scale your code on multiple nodes. So for that, you need to modify your code and run and use the typical MPI lines. So I will briefly mention on this topic because it requires sometimes to master the concept from MPI, and this should be linked to R as well. But essentially, for instance, in this script, I'm using the RMPI library, and this MPI universe is the number of cores that you requested in your batch script. And here I will generate some number of the so-called slaves or workers. In this case is 5, and they will execute some task. In particular, in this case, they will generate some random numbers uniformly distributed. And once the tasks are completed, you will close R slaves and finally finalize the task. So, so in case you are using RMPI and you have some issues, just contact us through the support. So, as I mentioned before, this is one of the packages that do not work with all the R versions, unfortunately, and you should be cautious on using that. And here I found one R version that works well, and the script is related to the R script. It's called rmpi1.sh, and here is the standard R version. Here I'm using R script, but it's the same as you use R. It's exactly the same. I don't get any difference. So just that here I changed that. I took that from a previous example I had, but essentially it's the same using R or R script. And here is the R. So the only difference is that here I'm not using the -f because I'm using here R script, right? And this flag is just to uh, avoid some warnings from MPI that you get. So you need to change here the project ID and submit the file. So the other RMPI examples are very similar, and they are doing a simple task. So what I won't go into the detail of RMPI. So if you have questions of RMPI, just let me know about that. So the next example that I will describe is called do parallel. I would say this is more friendly in the sense that you don't need to parallelize the code, but instead you use some parallel code that do parallel has already parallelized. So in do parallel, I prepared these two examples, do parallel.r and do parallel machine learning R. So I will mention this one first, do parallel.r. And here, this is the place I took the example. And for using do parallel, you need to load the do parallel library. And you work as usual. First, load the database, set some variable, and here I put a sequential version of the code. So do parallel includes a for each definition, and it uses the parallel package as a backend. So this code runs in sequential mode using one core, because here I'm using the do instruction. So for each will run using a single core, and I call that sequential version. And after that, it will print the sequential time. So, but you can also run this code in parallel mode, and in particular here I set the number of workers to 4. And first, when working with do parallel, you need to make the cluster and then register the cluster. And if you use a for each, you use do par instead of par, instead of do, as I did above. So then we print out the time that it takes. So I will run this script. And here is the batch script. I will take a look at it first. You see the standard commands. Now I'm requesting 4 cores with the -c line, and the R module is the same as before with the same lines, right? So I will copy and paste the project type. And it is here, and I will submit the job. Now I check the queue. and it's running. If it takes a long time, and you see now I'm using 4 cores, I can check that with the job usage and one and the rest of the numbers here like this. So now I check the output, which is written in the standard Slurm output. And I can check the time. Let me see if it has finished. No, it's still running. So if you want to monitor a job that is still running, you can use the command tile minus F and N and the number of lines that you want. And it will allow you to monitor the evolution of the log file and the evolution of the program. So the job has finished, and you see that the sequential version took me 20 seconds, and the parallel version with 4 cores took about 7. So now at this point you can see that the scaling is not perfect, because if you have if it took 20 seconds with 1 core, we expect it to be 5 seconds with 4 cores, right? But the scaling is not perfect, and that's always the case in HPC, or in general that's the case. And it is recommended that at the starting of your calculations you do some initial profiling by changing the number of cores that you have. This is not only for R, but in general, so that you don't use more than you need, and also you don't use less than you need. So it would be good for your raw flow. Uh, and you see that its scaling is not perfect because it involves many different things, especially in R, because R needs to set the environment. Sometimes it does unwanted duplications of data and many different things. And yeah, so a message from here is that you can profile your code, not only with R, but with other software as well. So I also prepared another example for R, for a machine learning model, and we can take a look at it. So in this case, I am loading several packages from R, and also several models. And here, at the end of the script, I'm executing the code in serial with a do instruction, and also in parallel with a do par command. And then I got the times. So this is a common way to run scripts. But be aware that R can do some duplication of data. And here, if you see, I'm running a expensive function and training many different types of models. So sometimes you think that this is a optimal way to work, but you should also consider that if you run the scripts separately, then you can get the most expensive ones working independently, and run the others by using other separated scripts. So that could help. Also, especially if the models are being duplicated in the scripts. Consider also, for instance, if you have a large database you're working with, that maybe you could split the data and feed the models, and that could help you. And especially in R, because it does a data duplication, you can use the job usage command to monitor how much memory you are using in the script. And it's easy to get above the limits of the nodes in Kebnekaise, which are about 120 gigabytes. It's easy to get above that with R. So the way to submit that is by using this script, job parallel ML, and it's exactly the same as previously. And here, notice that I'm using 8 cores, and this number 8 cores should be the same as in your application. The same as here. Here, number of cores 8. So, but uh, again, it doesn't mean that if you use more cores, that your script will run faster. That's that's not true. So you need to monitor your script and pay attention to your resources. Okay, let me go to the next model. This is a machine learning script. It's similar to the other ones, so you can take a look at it. And it has a sonar data where one partition the data into training and testing, and also one does some fitting procedure, and one train the model. And I'm monitoring the time that it takes in serial mode and also in parallel mode by using 4 cores. And the way to train this random forest model is by using a similar script as I did before. And I use it as the same R version. So you can also try that if you are interested in this more specific model for R, right? So let me go to the next application, and this will be MATLAB. So I will go to the folder called MATLAB, and here I prepared several examples. And here is the serial version, one serial version of R, then a PAR4, a GPU, and SPMD. So how to use MATLAB? First of all, if you notice, I have loaded, if I type ML, this will give me the modules that I have loaded on the terminal, and they are related to R. So if I load now the MATLAB version, it will conflict most probably with the modules that I have loaded, and because of that, I will purge the list, and now I will search for MATLAB, ML Spider, Matlab, and this will give me the Matlab versions that are installed, and I will use this one. I will explore first for the dependencies of Matlab, and it says that it can be loaded directly without any dependencies. So then I will load that version. Okay, so it's loaded. And one thing, so I will start Matlab in this way. Matlab dash a single com thread, and this is uh, essential, I would say, because otherwise Matlab can start many threads on the login node, and this will cause a overhead in the login node. So it's much more better to use this line, which I pasted on the chat. So if you do this, I will get the Matlab interface. Also, at this point, one could be tempted to run the scripts on by just pressing the run command, but this is not a good idea because we are now in the login node, and this will cause some issues for the other users. So it's better to use the batch uh, queue. So let me open the files in the serial directory. I will go to this place here, open, and search for the serial. And these are the two files that I will mention here. First the func file, and then the submit file. So here is a simple function for doing some Fourier transform operation on a matrix, and then uh, I will print out the log files, and this is a submit file for this particular function. So it's important to notice that in MATLAB uh, we prefer to use MATLAB itself for submitting the files instead of using the batch scripts as we mentioned before. And that's because MATLAB has a good integration with the Slurm, which allows you to submit and control your scripts by using MATLAB. So that's why here my submit script is done through MATLAB. But notice that we need first to declare this cluster. And if you go to our website, let me see. Do you know how to escape from this window, Birgitte? Because no, because I'm sharing, I cannot see my local browser. Oh,
Okay, that's good one. Try push the Alt and the Tab.
Which one?
Alt, Tab, this one and that one at the same time. That should let you change windows.
I see.
I don't know if it works but it doesn't.
Okay, so if we go to the HPC2N website, and then we go to software system support and software, and then go to MATLAB here. You will see some instructions that you need to do in order to use MATLAB for the first time. So it's not straightforward to use MATLAB for the first time, and you need to follow some initial settings. So like here, in the configuration and setup, you need to follow these lines. So first, on the MATLAB window, you need to type this command here. Let me show you. Config cluster. You run this command config cluster and follow the recommendations that it gives you. So I will try that right now, although I did that before. So it asks you about the two type of clusters. Neglect Abisco, because Abisco is not longer active. So I will choose Kebnekaise, and then it will ask you for some additional options that are written on the website. So for instance, here you can set the account name to your account name, to your account that is the SNIC project. Is not your name or any other name. It's just the SNIC project. For instance, in this case, is SNIC 2020 and some other numbers. But this project will be available just for a few days more. So you need to have a valid project for this. And once you set this value here, you can also set the additional time or the wall time that you will ask by default. And here is 5 hours, but you can use also just 10 minutes or whatever you want. And finally, when you're happy with these options, just type the last line, C, and save profile. And it will save the profile that you have written. So in case that you want something more specific about your program or your cluster, you can go to, let me see, in home, you can go to home and then go to parallel and to create and manage clusters. and this will give you the options that you have. In this case, I have two options: the Kebnekaise and the local. Local means the login node, so we don't recommend to use that. And Kebnekaise has the following options.
It will say simply get permission denied from number 2.
For what? Sorry.
Kebnekaise probably. So then they're getting permission denied when they click Kebnekaise.
Permission denied for what part? Sorry.
When they try to configure the cluster and get pick Kebnekaise, then
Okay.
permission denied. So that's some weird error. Maybe tell them to delete.
Okay. So let me then go to this configuration step, because this is crucial for you to use that. So I did it before and it worked, but maybe this time I don't know. So I will use uh, the following lines: C park cluster, and the name of the cluster is Kebnekaise. Then additional name. I will just copy and paste the project name. What was the project name? Sorry, Birgitte. SNIC
SNIC 2020 -9 -215.
200. So this is the project name that we have now for the course. Yeah, and I will request for 5 minutes or maybe less than that. And now I will save the profile. So seems to work. And because I have configured already this profile or this cluster, I can then come to the submit job and run the code with this button here. Editor, you go to editor and run, and hopefully it will run. Okay, it is asking me for changing the folder because I am not in the folder that is where the submit file is, but I will just change the folder, and it says account or partition not specified, combination specified. So let me check the project name. Okay, the project is not correct. It's 215. So I will run again these lines here. Configure cluster 2, and then I will run this 215, I think, and then the time, and finally I save the profile. Oh, sorry. Sorry, I didn't write the cluster name. What question? Sorry.
Pedro, will you discuss how to install other open source programs and the general ideas of how they can be used?
Yeah. Yes. This is idea that I will discuss about other software, um, and I will talk about MD codes later on. And here I'm trying to configure the cluster in case you want to do that. And here I define the cluster name, part cluster, then the account type, the time, and finally I save the profile. And if you do that, and then you try to run the script, it will run. So it's submitted, and it should be on the queue. So if you check again with your terminal your name, and you see that the job is running here, and it is from MATLAB, right? Okay, there are other type of scripts that I provided to you, and there is one for GPUs. But be aware that if you use GPUs, you need to make a profile that uses GPUs. And you need to follow this line here, especially when you create the cluster, you need to add these GPUs instructions, because otherwise the cluster won't be able to recognize that. So what I will not do that at this point. What we did was to create a cluster that uses pure CPUs. Okay, now let me go to a different software, and this will be GROMACS. So I will talk about just the most common applications, as I said, and GROMACS is, I think, the largest one that is being used in HPC2N. And if you remember, I loaded previously MATLAB, and because of that, I will purge, and then I move to GROMACS folder. Here there are two examples, one GPU and one MPI. And I will go first to the MPI part. So I provided you with a TPR file and two scripts for running GROMACS with MPI version, and also a tune PME script. This is very useful if you want to profile your script. So let me open this part, MPI. And this here I'm loading a old version of GROMACS. I'm using that because it is old, but it's also very stable. It supports many algorithms, and it's very well tested. So this is the way that I used to run GROMACS. So please notice that this is just a very basic script for running GROMACS. GROMACS is a program that can be optimized with several options for MD run. and we will offer in this period, I think in April or May, we will offer an MD course where we will touch more in April. In the end of April, we will offer a course on how to tune these options in GROMACS. So, but this is the most basic way to run it. And basically here I'm using 4 MPI tasks and 7 OpenMP threads, and they are reflected here in this environment variable. But I'm not optimizing anything in the batch script. So GROMACS is very robust, so it can run easily, but it doesn't mean that the simulation is efficient. So you can tweak these options to get a better performance. So to do that, you can use this script here, the job tune PME, and this will tell you some optimal values that you can use for running md-run command. Now let me go to the GPU example, and here I'm using a different version of GROMACS. It's the 2019, and here I provide you with different ways to run a GROMACS. One is the default version, and some tweaks that I did, and you will find that it runs faster, about 30 to 20 to 30% faster than the default version for running GROMACS. So one comment from the developer of GROMACS, Mark Abraham, is that if you will wait for your simulation more than a week, then it is time to invest some of your working time in learning on how to tweak the GROMACS options. But if it runs just for 1 or 2 hours, then it's okay to run with the default version. So also you can write us a support ticket if you want to get a more efficient script for running your GROMACS code, and then I can assist you. So now let me go to another popular software, which is Amber. And some words about Amber is that it can run fully on the GPUs. And here on this script job, GPU PEMEMD, you can see the way that I'm using to run it. So I'm using the PMD CUDA MPI command. And Amber is able to detect the number of GPUs. So these numbers here are a bit misleading because here, if you request for 2 GPUs, it will tell you about the number of GPU cards, but each card has 2 engines. So in total, if you request 2 here, you will get 4 GPU engines, and that is what GROMACS and Amber will recognize. So they will be using 4 GPUs. So in this case, it's 4 GPUs because I'm requesting also 4 tasks. So these programs use the same number of MPIs for the GPUs. Okay, you can try this example as well. And now I can move to my next example, which is lamps. Is there some break? No.
No, we were talking if we should have, what you also
I see.
discussing the survey, what to do about it.
Yeah.
Should we take a brief break?
I think so. Yeah.
Yes, I think we should.
Okay, before going to this lamps example, we can take a short break of 5 minutes, and we will come back at 16:15. Any other software that you are using and was not discussed today, or something that you want to see? So we are trying also to do training courses regularly. And if you take a look at our website here, you will see that besides this course, we are offering other courses, and some of them are in the coming months. We will teach some R in HPC, and also a OpenMP course together with other SNIC centers. I will also teach a MD course because for these applications you need more time than this course, which includes several software. And here I will go in more detail on how to use R in an HPC environment. And for this course, I will talk about how to use a better or more efficient scripts. So the ones that I mentioned today were the default options, but you can tweak the options for the scripts so that they run 30% or yes, maybe 40% faster than with the default options, but you need to know more things about that. And my colleague Mirko will do a course in task-based parallelism. So
There was also someone who asked about, I saw some of the surveys of the, someone, there are people who want courses on profiling and courses on GPUs.
yeah, so if you are interested in some course in an HPC environment, you can always request for that in the support list. So previously, we offer, for instance, a profiling tool course, uh, and we can offer that again. So something that happened before is that we offer courses like the profiling tools, but there were not so many participants, and that's one thing it tells us if we offer that again. And but now with the Zoom meetings, then we can get more people, and maybe that's useful for a broader audience. So we also offer previously introductory course to MD software. So I taught before how to use GROMAX and NAMD, if you see on the website. And so if you are interested in that, send us a support ticket, and if we get enough people, then we can redo that courses. Something that we are planning also is an introductory course to Git, because it's very useful and upon working with an HPC environment. So please send us a course.
Yeah, Pedro, there is I'm not sure how to pronounce the name. Mitchell, who apparently had some issue. I don't know what it's related to.
So it's on the
On a chat.
on the chat. Let me see. Also, one thing is, as Mirko mentioned, that is that you can apply for some time from the application experts, and then we can look at your specific project in more with more detail. So in my case, I'm working with the MD applications and also profiling tools. Yeah. And some of the computational chemistry, quantum chemistry codes, such as Gaussian or yes, BASP, or some semi-empirical methods for QMM calculations. Mirko is working with GPUs, and Jerry and Birgitte with parallelization tools. Is there any other question from your side? Any other comment?
Should we just wait 5 minutes if someone comes up with some questions?
Yeah.
Yeah, and then
So
yeah.
we can have the last 5 minutes for any other comment that you could have, any other question, and then we will finish this course. And I hope you got an idea of our system and how to deal with it. And feel free to write a support ticket if you have any further question when you start working with your software.
And one thing that we have a course survey that we have linked in the Q&A page and also in the Zoom chat. So after the course, we would appreciate if you have time to go and fill it in. That would help us to do changes to the courses and plan any future courses.